Howdy ho, Mrs. Zookstra here. We are working on Module 3, Lesson 15 today. I'm on page 113 of our book. Lesson 13 is Graphing Solutions to Inequalities. And today our essential questions: when graphing an inequality, how do you determine the type of dot used? And which direction do you shade? So we're going to be talking about our inequalities and finding all possible solutions, and that's what this whole graphing part is about. All right, so let's take a look at exercise 1. I actually am going to read it to you, and then we're going to pause and see if you guys can try to figure it out a little bit. So two identical cars need to fit into a small garage. The opening is 23 feet 6 inches wide, and there must be at least 3 feet 6 inches of clearance between the cars and between the edges of the garage. How wide can the cars be? Well, first thing I'm going to have to do is change everything into all feet or all inches. I personally would rather change it all to feet. So I am going to change 23 feet 6 inches into 23.5 feet, because 6 inches is half a foot. Okay, and then the same thing for the clearance, those spaces that we need in between the vehicles and the edge of the cars to the side of the garage, that is 3 feet 6 inches as well. So I'm going to change that to 3.5 feet. All right, so I'm going to pause here a minute. I would like you guys to start off by trying to draw a diagram of what this might look like, okay, and try to kind of help you figure this out. And when you have a drawing figured out, maybe from there you can start working on it. If not, and you're like, yeah, I have no idea, go ahead and unpause the video. But I'd like to see how far you guys can get without my assistance on this. So hit pause right now. Okay, so I drew my sketch. I drew what I thought would look like kind of like a garage. And I put my two cars inside. I put the dimensions on there, 23.5 feet and the 3.5 feet. And that's what my drawing looks like, right, with the 3.5s in between all the spaces. So to write my equation, my inequality, I have 3 of those 3.5s plus the 2 cars. And I said X was the width of the car. And it all has to be less than or equal to 23.5 feet, right? It's okay if there's more than 3.5 feet in each space, but it has to be a minimum of that. All right, so 3 times 3.5 gave me my 10.5, and so then I just subtracted that over to the other side. So I got 2x is less than 13, divided both sides by 2, and I got 6.5 feet. So each car is less than or equal to 6.5 feet. Now let's talk about this a minute. We're making an assumption here that we need to kind of discuss and figure out. A car cannot be negative feet, right? It can't be negative width. So a car has to have at least a couple inches. I know that sounds really crazy to say. So it has to be wider than, maybe we should say that instead of at least, has to be wider than 0 feet, but according to this last thing that we just figured out, but less than or equal to 6.5 feet. It's okay if it's exactly 6.5 feet, and it can be anything smaller than that, and of course we can't have negatives, so it's got to be greater than 0. So if I said, let's draw this on a number line, all right, so just draw yourself a number line really quick. Okay, I don't need to worry about my zeros or negatives. I should say negatives. I don't need to worry about that. So I'm going to go 1, 2, 3, 4, 5, 6, 7. There. Okay, so I've got that there. It can be exactly 6.5 feet. So what I'm going to do is I'm going to put a dot at the 6.5. Because 6.5 is included, I'm going to color in the dot. It is included in my solution. All right, now let's talk about the width of the car. Cannot be 0. There's no such thing as a 0 foot wide car. Granted, there's no such thing as a ½ inch wide car either, but we're just going to go with it. So all of my answers in between these two, right? Everything in between these two. If you've got a pencil, you could color it really dark. If you have a highlighter, this would be a great time to use that. All the answers in between right? The car could be 6 feet. The car could be 4 feet. Smart cars are really small, right? We don't know. It could be any of those. All right, so those are all the possible solutions. We'll talk more about these dots here in a little bit. All right, let's go to the next one. Page 114. A local car dealership is trying to sell all the cars that are left on the lot. Currently, there are 525 cars on the lot. Okay, that's how many we have. And the general manager estimates they will consistently sell 50 cars per week. All right, there's my rate. Estimate how many weeks it's going to take for the number of cars to be off the lot. Okay, so what we're going to do is we're going to use W for the number of weeks, right? W is the number of weeks that we're going to work with this. And they want this to be, they want to know how long it's going to take to be less than 75. All right, well, we currently have 525 cars. And we're going to sell, which means they're being removed, we're going to sell 50 cars every week. And we want this answer to be less than 75. I want to know how long it's going to take to have fewer than 75 cars on the lot. All right, well, I solved this like I would if this was a simple equation. So I'm going to subtract 525 from both sides. And some of you are going to panic and you're like, Mrs. Hoekstra, we're going to get a negative answer. That's okay, because I also have a negative 50W. All right, so we're okay. And so 75 minus 525 gives me negative 450. Okay, so now I have negative 450, and I'm going to divide both sides by the negative 50. And negative divided by negative is positive, that's good. But when I divide by negative, my sign reverses. Catch that, right? We have to change the sign. 450 divided by 50 just gives me a lovely answer of 9. So it's going to take 9 or more weeks, more than 9 weeks, really, I should say. It will take more than 9 weeks. Okay, so now that we know that, again, let's make a number line. So draw yourself on a line. If you have your handy dandy straight edge, that's awesome. Now, whenever I make a number line, I kind of like to put the number I'm working with, I like to put it in the middle, actually, because sometimes I'm like, I don't know which direction I'm going or whatever. So I'm going to put 9 in the middle, and I'll just do 8, 7, 6 over here, and 10, 11, 12 over here. Right, just counting by ones, each one represents a week. Now look at that inequality. 9 is not included. If I sell, right, if I put 9 into my equation, I have exactly 75 cards. I don't want exactly 75. I want fewer than 75. So 9 is not included in my answer. So I'm going to put an open dot on there. It's not included, but it needs to be every number greater than 9. So which direction do I shade to go greater than 9? I'm going to shade to the right. And I'm going to put an arrow on the end of it because it can keep going forever and ever and ever. Well, supposedly, until we get to 0, I would guess, or they're going to replenish the cars. All right, so I'm going to shade everything to the right and put an arrow so it indicates that I'm continuing on forever. Okay, and that's how that one goes. This is not including, okay, this is not included in the solution. 9 does not work, so that's why it is an open dot. Okay, all right, let's go over to the next page. Exercise 2. The cost of renting a car is $25 per day plus a one-time fee of $75.50 for insurance. How many days can the car be rented if the total cost can be no more than $525? No more than $525. So I can spend $525, but not anything more than that. All right, so let's write our equation. We have $25 per day. There's my rate. And I have $750 one-time fee, right? A one-time fee. So I have $75.50 plus the $25 for every day. What letter do we want to use for day? Let's use D. D for days is going to be less than or equal to $525. Okay, because I can spend $525 and less. I cannot spend $526. All right, so there's my inequality. And so now let's go ahead and solve it and we'll graph it. I'm just going to work from here. So I'm going to subtract $75.50 from both sides. And you guys can grab your calculator if you need to be able to solve this. So 25D is less than or equal to, and 525 minus 7550 is $449.50. All right, now I'm going to take that and divide by 25. Divide that by 25. D is less than or equal to, I get 17.98. So how many days can I rent this car? I can rent it for 17 days, right? I can't round this up to 18 because that's more than $525. So I can rent the car for 17 days. Can I have it exactly, or less, I should say, or less, right? Or less. Let's make a number line to demonstrate this idea. Okay, you can put it above it, below it, wherever you got space for your number line. So I'm going to put, you know what, I don't have space for it there. I'm going to move it. Let's move it down. Oh, come on. There we go. So if I move it, I'm going to put 17 right here in the middle. Right, 17, 18, 19, 20. And then we have 17, 16, 15, 14. There. What kind of dot will 17 get? Can I actually rent the car on the 17th day? Definitely. I can rent on the 17th day. I'm going to put a solid dot on the 17th day. And I can do any day less than that, so I'm going to shade everything to the left. Okay. Now I know you guys are all looking at this going, but the answer was 17.98. Yeah, I could probably put it at 17.98, but nobody rents, like, you know, you either rented it for the whole day or not. So we actually have to round it down to the 17. All right, take a look at this next one. We're going to pause and we're going to have you try this one. Okay, let's read it quickly together though. Mrs. Smith decides to buy 3 sweaters and a pair of jeans. She has $120 in her wallet. If the price of the jeans is $35, what's the highest possible price of a sweater if each sweater is the same price? All right, so I want you guys to pause right now and try to figure this one out on your own, including the number line and interpreting. Give me an answer in a sentence. Okay, so I said 3x plus 35 is less than or equal to 120. I subtracted 35, divided everything by 3, and I got 28.33. And yes, I can use the 0.33 because we're referring to money this time. And so I can actually have it all the way to the nearest penny. So I actually counted by thirds in my number line. And then I shaded a solid dot because 28.33 is the most it could be, and anything less than that, right? So each sweater can be no more than 28.33, or you could say each sweater can be 28.33 or less. Okay, that's another way of saying that one. All right, let's go to the top of the next page. So the members of a select chorus agree to buy at least 250 tickets. I'm going to underline that. At least 250 tickets for an outside concert. They buy 80 less lawn tickets, than they buy balcony tickets. Lawn tickets is less than the balcony tickets. What's the least number of balcony tickets bought? Okay, so I'm going to have balcony tickets. And we have lawn tickets, right? So I've got the 2 different types of tickets, and we know that it's going to be less than or equal to, or excuse me, greater than or equal to 250. I'll get into that in a minute. I also know that the lawn tickets, right, that's 80 fewer than the balcony tickets. So if I'm using B for balcony tickets, lawn tickets is actually the balcony tickets minus 80, right? However many I got of those, subtract 80 from it, and that's how many lawn tickets I have. So I could write this as balcony plus the lawn tickets is going to be greater than or equal to, because they have to buy at least, right? That means 250 or more, right? 250 or more is how many they're buying. So I can't deal with the 2 variables in there, so I'm going to write the first one, the balcony tickets, plus, instead of writing L, I'm going to write B minus 80. And that is going to be less than or equal to 250. Okay, so now I can just start combining like terms. I can add my b's. So I have 2b minus 80 is less than or equal to 250. I'll add the 80 to the other side. And I have 2b is less than or equal to $330. Or excuse me, 330 tickets. Divide both sides by 2, and b is greater than or equal to 165, which means that they bought at least a minimum of 165 tickets. They bought a minimum of 165 balcony tickets. Okay. All right, if we drew this on a number line, I'm going to put my number line, I think, over here just because I'm running out of space. If I put my number line over here, I'm just going to put my 165 right here in the middle, 66, 67, 168. And there's my numbers. I'm going to put a solid dot on 165 because I did buy that many and more. So I'm going to shade to the right. All right, last problem. So Samuel needs $29 to download some songs and movies on his iPod. His mother agrees to pay him $6 an hour for raking leaves and in addition, to his $5 weekly allowance. So he automatically gets the $5, but he's also going to get $6 an hour, and he needs to make at least $29. So he has $5 that he gets for his allowance plus the $6 per hour. I'm going to use H for number of hours. Okay, and this is going to be, let's see here, greater than or equal to 29, right? Because he needs $29 or more. If he has more, awesome. If he has less, he doesn't get to do what he wants. All right, so I'm going to subtract the $5 over to the other side, and I get 6H is greater than or equal to 24. If I divide both sides by 6, I find out that H is greater than or equal to 4. So he needs to work at least 4 hours, right? He must work at least 4 hours raking leaves. And right this time of year, perfect, right? There's lots of leaves to rake. All right, let's make our number line for this one. So I'm going to make my number line. I'm going to put my 4 right in the middle because that's just kind of how I like to do things. Okay, so I got 4, 5, 6, 7, 8, and then we'll go 3, 2, 1, 0. He can't make negative money. That'd just be weird. And H is 4 or more, right? 4 or more. So I'm going to put a solid dot on 4 and color everything more. Of course, he could work more than 8 even, right? Raking leaves. So I'm going to put an arrow on the end of it. Now, if you haven't figured out what kind of dots go on everything, I'm going to talk about that in class. If you think you know what kind of dots they are, then great, put it down here, right? What ones get open dots and which get closed dots? If you figured it out, write down your hypothesis, your conjecture, and we'll see if you have figured it out right when we come back to class. I'll see you all later.